Okay, guys, you 12 calc guys. These are the answers for page 12 for the hyperbolic graphs that I've asked you to look at. Okay, this one here, you can see that the graph goes like this, and down here it goes like that. Now this means it's approaching this dotted red line, this vertical line, which has the equation of x equals 2. In other words, this curve is approaching this line, but never crosses it. It gets closer and closer. If I were to continue on for infinity up there, this curve would get closer and closer to this line, x equals 2, but it would never cross it. And the same is true down here. If I was to continue this to infinity, this curve would get closer and closer to this red line, but would never cross it. This is why this is called, this special name is given to this type of line, is an asymptote. So we have an asymptote here along x equals 2. If we look at the way the graph behaves going this way, we can see that it's getting closer and closer to this line here, this red dotted line there, and the same is true of the curve going this way. Well, this line here is y equals 1. That's its equation. So it too is an asymptote. So of the features that we're quoting, x equals 2 and y equals 1, they are both asymptotes. Okay, so when we look at the equation, we have to build up the equation, keeping in mind what these asymptotes are. Because when we write the equation, we're going to write y equals k 1 over x. But in this case, the standard hyperbola has been moved 2 units this way to this asymptote here. It's gone 2 units this way. So we write x minus 2, even though the hyperbola has been moved in the positive x direction, we write negative 2 here. So our equation must start y equals k 1 over x minus 2 in brackets. Now, because the standard parabola has been moved up by 1 unit, we have to write a plus 1 on the end. That's this plus 1. This does not change sign. It's been moved up 1 unit in the positive y direction, so we put down plus 1 there. Okay, so look, we've now almost got the equation. However, we don't have k. So we've got to find k. So you choose a number, a point, sorry, on the curve that is easy to use. Now I used this one there, okay, 1, 2. And if you put 1 for x and 2 for y into this equation and solve it, you will get k equals minus 1. So you'll have 2 here for y, you will have 1 here for x minus 2 is minus 1. You're going to take that plus 1 over the equal sign, and it'll go to minus 1. So you'll have 2 minus 1, which is 1. And so you'll have 1 equals k, 1 over minus 1. So you've got this k is being multiplied by minus 1 effectively. So the only way that can happen, if k times minus 1 is equal to 1, is if k itself is equal to minus 1. So your final formula is that y equals minus 1, that's k, over x minus 2 in brackets, all plus 1. Okay, let's go on to this one here. Now this one, we can see again, if we think about it in the same way as the previous one, we can see that there's an asymptote going that way and an asymptote going that way, and that asymptote is this y equals 1 line. Okay? Similarly, if we look at where this is going off to infinity, it's going to be approaching this red line here, this vertical asymptote, and the same is true here. It's going to be, curve is going to be coming down closer and closer to x equals 1, but never touching it or never crossing it. So we've got two asymptotes, y equals 1, x equals 1. So let's build up the equation. Well, there it is. It's the standard hyperbola has been moved 1 unit in the positive x direction, so it's going to be 1 over x minus 1. Now it's been moved up 1 unit in the y direction, so it's got plus 1 on the end here. Okay, so we don't know, we know, almost have got the equation, we just don't know the k value. So I looked for a point. I could have chosen that point there. I could have chosen even that point there, yeah, which is 0, 5. And I chose this one at 6, 2. So if I put 6, 2 into this equation, that's 6 for x and 2 for y, and solve it for k. So y is 2, x is 6, 6 minus 1 is 5. Take the plus 1 across, the y, which is 2, this plus 1 goes to minus 1, so it goes from 2 minus 1, making it 1. So you've got 1 equals k, 1 over 5. Well, if you cross multiply the 5 up here, you get the k is equal to 5. And there's the final formula there. Now there's the features. X equals 1, x equals y equals 1, both of which are asymptotes. And because k's value comes out positive, it is a positive hyperbola. I did forget over here just to point out that because k comes out as negative, it means that the hyperbola is described as being a negative hyperbola. Okay, now let's look at the ones at the bottom of the page, on page 12. Okay, so here we are there. So this one, again, well, it's the standard hyperbola, but look how far down it's been dropped. It's been dropped 1, 2, 3, 4, 5 units. This is an asymptote then at y equals minus 5. But notice there's been no horizontal movement of the standard hyperbola. So it's just going to be 1 over x there. Okay, there's no plus or minus of the x there because this is just, there's been no movement horizontally. Okay, so we can immediately write the equation as y equals k times 1 over x minus 5. This little dot there, by the way, is not a decimal. It's just a very simple way of writing multiply. Okay, so again, I'm looking for how to find k. Well, I look for a point that is easy to use. Now, I could have used this point here, which is 1, 8, but it gives me big numbers to play with. So I looked for something a bit smaller, give me smaller numbers, even though they were negative. And there I used this one here, minus 1 and minus 2. That sits nicely on the curve. And so I put those coordinates into this equation and solve it for k. So the y is minus 2, the x is minus 1, so we've got 1 over minus 1. We're going to take the minus 5 over, well, then it goes minus 2 plus 5, which is plus 3. And then we've got 1 over minus 1, so that becomes minus 1. So we've got 3 equals k times minus 1. Well, the only way that can be correct is if k itself is minus 3. And so there's your final formula. Y equals minus 3 over x minus 5. Again, you have to state in the features that the y-axis is an asymptote and, the y-axis is an asymptote and the line y equals minus 5 is an asymptote. And because k comes out negative, you're dealing with a negative hyperbola. All right, let's look at this one here. Well, this one is the standard hyperbola. Okay, it's not being moved horizontally, it's not being moved vertically, so it's going to be just y equals k times 1 over x there. So all you need to do is find a point through which it goes. Well, they've made this quite tricky one because there's no nice whole number coordinates it goes through. So I've chosen that one there. At least my x value is a nice whole 1, but my y value is 1/2. So if I put those values into this equation, I get 1 divided by 1, which is my my x, and the y is 1 over 2. So I get that k, if I work that out, k comes out because it's 1 over 1, and so it's 1. So it's 1 times k is equal to 1/2. So k is equal to 1/2. And you put the half back where the k was, and there's your equation there. Y equals 1 over 2x. This is the same thing as 1 times 1 over x. Now, features, both the x and y axes are asymptotes, and the hyperbola is positive, because even though it's a fraction, it's a positive fraction, so you've got a positive hyperbole. Okay, now I will give you, I will put up on Teams some exercises for you to do like this. I might go to Desmos and do a few graphs for you to try for yourselves. Okay, I hope you found that that you understood what I was going on about, and I'll do some more videos later on. Okay, thank you very much.